Real quick, I need to get my AC plug on the line cord, and this is my modified design where we came through. I reversed the switch, put it on the other side, went through the fuse itself, and I'll expand more on the fuse and the amperage that I use there, the switch and the diode. So if we go back over here, I'm going to just place a lead on the diode itself here, and you can see when I was doing some troubleshooting early on, I skint this back, so this should be my hot side, and it is. I just wanted to double check that. Let me go ahead and get the AC plug on here. You can see I've got the reproduction, more authentic looking AC plug. So let's get those tubes in the radio, but just a little more housekeeping that needed to be done. I pulled out the tube tester and tested the tubes that were in here, the 4 that were available, and I was missing the rectifier tube. All 4 tubes test good, no shorts, emissions are good or good enough to try to bring the radio up. I think one of the tubes was just a little on the weak side, but nothing that should be a showstopper. I had already started cleaning these tube sockets from underneath best I could. I had used alcohol here, and I had used QD electronic cleaner numerous times from the top side and the underneath side. I've got the alcohol back out, and I'm just using a small brush here. These brushes are really handy. I've used pipe cleaners in the past, but for these particular tube and tube sockets, these little hummingbird feeder cleaning brushes really work well. And for now, I'm just taking some of the alcohol and going down through each one of the tube sockets again, just doing some scrubbing and letting that dry. I'll follow up here with some deoxit contact cleaner, and I'll do the same for the tube pins themselves, which I've already cleaned the pins using one of my scoring pads, just ever so lightly, but I'll go back over them with deoxit also. Let me go ahead and finish up with the deoxit. I've hit all the tubes twice now with alcohol, just to make sure there was no more beeswax in the tube pin sockets themselves, and then I think this should get me going here. By the way, the finished chassis from the top side, I think it turned out pretty well. You know, it's hard to be patient at times, especially when you've finished a recap, replacing resistors, doing some minor or major work on a radio. The first thing you want to do is go grab the power cord and plug it in. And I'm no different than anyone else. That's the fun part, you know, to see if there's any smoke, fire, or do we just hear a nice crisp audio out of the speaker. But there's still some basic tests that I want to do, and just kind of get them off my checklist prior to plugging this radio in for the first time. Let's start out by understanding the heater string real quick, and just make certain when I test off of my AC plug here, looking at continuity, that when I flip the switch on, we see something happen, just to make sure we don't have an open. we should read the cold resistance of the tubes. Or should we? Let's find out. Let's go ahead and hook up here. I want to understand the DC resistance here across my AC plug. And I'll go ahead and connect the positive lead here to the hot side of the plug, that being the brass, more narrow plug, and the neutral here being the wider blade. And let's see if I can lay those out of the way here. We'll flip on the meter, see what we've got, and I'll reach around. Let's flip the radio on. That looks strange to me. 1.6 million ohms of DC resistance. Why is that? Strange. But I think we can explain it. Let me go back here and I'm going to reverse the leads. And let's put the positive lead here on the neutral side. And let's repeat the test and see what we get. Radio is turned off. We'll flip it on. And nothing. One may think that you would see some DC resistance, and you typically would. What makes this set unique is the design changes that I made. You guys recall, I added a diode to help drop the voltage to the heater string. We had about 69 volts being used by the tubes themselves, so we need to take the line voltage minus that difference, and that's what the diode along with the power resistor is doing for us, or should, by design. So we won't get into a bunch of theory itself, but the reason we saw DC resistance on one side is really just the direction of current flow through the diode itself, and the current flowing from this position back to this position. But here's what we can do. Let me grab a small jumper here, and let's short out the diode for a moment, and then let's retest and see what the DC resistance is across these 2 points. Let's get that jumper attached here, and let's flip this on and see what we read. So right at 90 ohms of DC resistance. Let's reverse the leads now and see if there's a change. Okay, they're the same. So we've got roughly 90 ohms of DC resistance. Does that, pass the smell test? So let's look at the tubes and look at the cold DC resistance of the heaters of each tube. We'll sum those up. In addition, we'll add in the 56 ohms from the power resistor, and let's make certain that we get very, very close to 89 to 90 ohms of DC resistance. We've got the meter turned on, so we'll start right here with the rectifier tube and just work our way across. This is the 25Z5, and all I'm doing is measuring between pins number 1 and 6, the heaters, and we'll just call that 11 ohms. So let me jot that down. Let's move over to the type 43 tube. Same exercise. And you can see we're right at 11.5 or a little bit more. We'll call that 12. We'll drop down here to the 6, Charlie 6, or what would have been the 77 tube. You guys recall this is substituted tube. Let's do the same drill here. And we'll call that 3 ohms. Next tube over, the 6B7. Same thing here. Let's see if I can get down in here to the heaters behind this capacitor here. And 4.8. We'll just round up and call that 5. And one more tube here to test. We'll go back over here to the 6A7 and repeat that same process here if I can get to the heaters. And we'll just call that 3. Let's add these up. The 25Z5, we said we had 11, looking back at my notes. Then we went back up to the 43 at 12 DC ohms. That gives us 23. Then we come back down to the 6 Charlie 6, another 3. That gives us 26. Then we come back across to the 6B7. That was 5. So we rounded up there, I believe. It would give us 31. And then the 6A7 tube was 3 for a total of 34. So we're still short of that 90, but we still have the 56 ohm resistor. So if we add the 56 and what I say 34, that gives us the 90. Let's check this resistor. It should be relatively close to 56, and it is. So I hope that makes sense. You can see that we can very quickly, the way this radio is configured with no transformer, and we're just looking at that heater string, you can see we're right at 90 ohms of DC resistance. So I feel comfortable that the heater string is wired correctly. And you guys recall I tested the tubes, but we're just looking at the cold DC resistance of the tubes. I'm going to do the same exercise for the B+, and we'll reference the schematic there. And I've already done that once, but that's prior to getting the field coil and the output transformer back in the circuit. And I didn't look at the screen grids as well. So let's just do the test there. Look at the DC resistance. Make sure everything makes sense on paper before we go plug this thing in and create a bigger issue. Let me get my meter hooked up right here on C21. And then we'll check this path that you see highlighted in orange. Up to this point, we'll come back across. We'll go through the output transformer, this being the primary side, up and across to the plate on the 43 tube, which is pin number 2. Let's check the DC resistance between those 2 points and make sure that it's correct. See, we got the meter attached there. We'll go back over here so we can look at DC resistance. We said we would start here on the 43 tube, which resides in this area, pin number 2, and that will actually be this location here. You guys can see that on the meter, 0.363K. So I think we're good there, and here's why. Let's go back to one of my original documentation sheets. Not a fancy drawing, but effective. You can see my output transformer looking at DC resistance using my LCR meter, 365 ohms. and 365 using my fluke. So what that tells us, grab the schematic again. You can see what we're doing is just reading the DC resistance across the primary of that output transformer. So based on this test, our B plus, when we turn this radio up, should be fine back to this point. Now let's go back over to grid number 2, closest to the plate here on the type 43, and check there and make certain it's still good. You can see we had it highlighted in orange. There's no additional resistors between the B plus cap C21 and that point. Let's just confirm that one more time. We'll be testing pin 3 at grid number 2. So 1, 2, and 3. And that's what we should see. I feel we'll still be fine here, but we'll double check. You can see the plate connection here, that being pin number 2. We'll be going through a 50,000 ohm resistor, a 400,000 ohm resistor, before we get down to the capacitor. So we already tested prior to this video, we read 450,000 ohms roughly. Let's just check that one more time, just to be certain nothing has changed. 77 tube being here, which is the 6 Charlie 6, pin number 1, pin number 2 resides here. And you can see we're spot on. So back on the 77 tube, let's look at the screen grid here, being pins number 3, and it's this grid right here on the other side of grid number 1. And you can see it's grid number 2. You can see if you follow it down, it attaches itself here to R11, comes across, comes through R12. We'll be influenced by R11 and R12 and some of the other residual circuit over here. But roughly, since this attaches to ground, we can probably take the 1 meg and divide that by 2, and that will probably be somewhere around 500K. So let's check and see what we've got here. Pins number 1, 2, and 3. I think I feel comfortable with that number without doing the math completely. So that looks good in my mind. Let's move over to the 6 B7, 6 Baker 7 next. Back over to the 6 B7. We'll check from the plate back down to C21. And if we follow this, you'll see that we're looping through the L3 coil, coming down, coming across. So what we should actually see is the DC resistance here of L3 points 1 to 2. Let me see if I've got that documented in my prior documentation. I'm sure I do. We'll see what that is. Then we'll test to pin number 2 and see what the results show. Here's my documentation for the L3 coil, and we were referencing points 1 and 2, and you can see I have documented 61 ohms. Let's check now between the plate pin 2 of the 6B7 back down to the capacitor there, C21. and the 6 Baker 7 tube resides here. The old metal picofarad cap I can just touch right here, and there we have it, 60 ohms. So I think we're good there. Let's go over to the screen grid of the 6 Baker 7, and you can see here I notated the tube pin number 3, grid number 2, and if we follow it back down, you'll see it's a straight shot, almost, but we do go through resistor R8, a 20,000 ohm resistor, before it makes its way over here to the B plus side of C21. Let's see if we read close to the 20K here. We already said this was pin number 2, so just working in a clockwise position, pin number 3 will be right here. So you can get down in here and get a good connection. And that looks good. So we're just under the 20K at 19.8K. Let's move along over to the 6A7 right here. We'll have to refer back to some documentation again. Looking at the 6A7, if you look at the plate, pin number 2, you can see it comes across, and we're going through that first IF transformer on the primary side from location number 1 to 2. So we'll look at the DC resistance of that. You can see we come over, come down, go back across, come down, back through part of the oscillator coil here from points 2 to 4. And then it looks like we're in that B plus rail the remaining way. So let's go back and look at our documentation for the oscillator coil L5 between locations 2 and 4, and the same thing for L2 between locations 1 and 2. We'll take the sum of that number and check here and make sure that we're close. You know, moving along here, I think this is why documentation is so important. At least you can understand your measured results, whether they be right or wrong. Here's that L2 that we were looking at on the schematic. You guys recall the primary and secondary windings are almost identical, and they should be by design because they're just fine-tuned with the variable capacitors or trimmers. So roughly 59 ohms. If we go down to the oscillator coil, the piece that we were looking at from 2 to 4, right at 2 ohms. So we should see, what, 59 to somewhere around 61 ohms of DC resistance. Back over to plate number 2, or pin number 2, that being the plate of the 6A7. Let's check there and see what we've got. This one's easy to identify because the plate was our red lead running back over here to one of the variable trimmers or capacitors. So this is our pin number 2, and you can see we're spot on at 61 ohms of DC resistance. Let's look. I believe the 6A7, there's a screen grid there as well. The 6A7 is a busy tube. You can see the number of grids. Probably won't be able to read this well, but the grid that we want to look at here is closest to the plate. We'll look at that first. That's pin number 3. It's where grids number 3 and 5 tie together internally in the tube. And you'll see it comes down, comes across. Now, one giveaway, what we should read, is the same thing that we read on pin number 3 on the 6B7. which was just under 20K. And the reason for that, if you come down, you'll see we're going through R8, the 20,000 ohm resistor. So let's just double check pin number 3 on the 6A7 and make certain that we're close to that 19 to 20K that we read over here on the 6B7. Then we'll jump over to pin number 4, grid number 2. Pin number 2 is here, so pin number 3 is right there. And now that's pretty much a mirror copy of what we read over on the 6 Baker 7, so we're spot on there. Let's go over to pin number 4, grid number 2. Let's refer back to the schematic first. Here's grid number 2, pin number 4, and you'll see it comes down, comes across, back down, and goes through that same section of the oscillator coil that we looked at earlier that fed the plate of the 6A7. You guys recall that was right at 2 ohms, and from there it's a straight shot. So what we should see is about 2 ohms of DC resistance. Back over to pin 4, grid number 2 of the 6A7. Let's give that a check. And that's pin 2, pin 3. If I can get down here to it. And there's our 2 ohms that we're looking for. So that doesn't mean that we're out of the woods on the B+. You could still have internal failure of the IF coils themselves. There's voltage, of course, going across these capacitors. There could be arcing, there could be other problems, but I think it's important before plugging this in for the first time, just doing the basic measurements and relying on DC resistance just to better tell us the health of the B+ string. And looking back at the heater string, and I feel confident for plugging this in for the first time. So I think we've waited long enough. Let's get this thing plugged in, see what happens.